Hello and welcome to another episode of Twiml Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. In this episode, I speak with Mike Del Balso, product manager for machine learning platforms at Uber. Mike and I sat down last fall at the Georgian Partners Portfolio conference to discuss his presentation, Finding Success with Machine Learning in Your Company. In our discussion, Mike shares some great advice for organizations looking to get value out of machine learning. He also details some of the pitfalls that companies run into, such as not having the proper infrastructure in place for maintenance and monitoring, not managing their expectations, and not putting the right tools in place for data science and development teams. On this last point, we touch on the Michelangelo platform, which Uber uses internally to build, deploy, and maintain machine learning systems at scale, and the open source distributed TensorFlow system they've created, Horovod. This was a very insightful interview, so get your notepad ready. Before we jump in, over the last few weeks, you've heard me talk quite a bit about our My AI contest, which explores the role we see for AI in our personal lives. We received some outstanding entries, and now it's your turn to check them out and vote for a winner. Do this by visiting our contest page at twimlai.com/myai. Voting remains open through Sunday, March 4th at 11:59 p.m. Eastern Time. One more quick announcement. Join us on Tuesday, March 13th for the next Twiml online meetup, in which our presenter, Sean Devlin, will be doing an in-depth overview of reinforcement learning and presenting the Google DeepMind paper, Playing Atari with Deep Reinforcement Learning. Head on over to twimlai.com/meetup for full details. And now, on to the interview. Hey everyone, so I am here at the Georgian Partners Conference, and I have the pleasure of being here with Mike Del Balso. Mike is the product manager for machine learning platforms at Uber.
Yep.
Mike, welcome to This Week in Machine Learning and AI.
Thanks, happy to be here.
It's awesome to have you, and I especially love it when folks tell me that they actually listen to the show before I'm about to interview them.
Yeah, I listen to almost every episode at the gym.
Oh, wow. Nice, nice. Do you put it on like 1.5x? Or
I actually do. I have some thing where other people can't stand it, like when I play podcasts for my friends, but it's got some setting to skip spaces and to just go 1.5x. So it just sounds really weird, but I got so used to it, it doesn't bother me. That's fun.
I listen to a ton of audiobooks and podcasts, and I tend to listen to at 1.5x. And, it's to the point where, like, if I hear the person slow down, they sound all weird. So do I sound like really weird and slow talking right now?
It's not the voice I was expecting. But there's actually like little jingles in front of different podcasts that when I listen to it at 1x, it just sounds weird, like because it's so down pitched or whatever. I don't know. It's weird. So I guess this podcast has that too, right? There's a little jingle.
I'm not even going to try to reproduce.
Don't do it.
This is that robot. It's called Robot Race. But yeah. So the routine, right? How'd you get started in machine learning and AI?
Yeah. So I'm a trained electrical engineer, and
Go double E.
Right on. And so we're in Toronto right now, and I went to University of Toronto. And when I graduated, I got hired as an associate product manager at Google.
Okay.
And the associate product management program is the way that they hire product managers directly out of school. Okay. And it's a rotational program. So they put you on one team for about a year, and then you switch, and they put you on another team for a year, and then you can switch again if you want. And so my first role was on maps, and I worked on maps data kind of stuff. And then my second role was on Google's ads auction team. And I was the product manager for some of the teams that generate a lot of the machine learning predictions for the ads auction.
Okay.
And so the kinds of predictions you'd want to make are, how relevant is this ad to the query that somebody is searching for, or how likely do we think someone is to click this ad?
So just a tangential little product at Google.
It was super important. It was really interesting because it was super important, and we would make changes that would have gigantic financial impacts. And it's a lot of really big numbers and dollars that you work with, and it could be hundreds of millions of dollars change you'd make. But at the same time, you work with really small numbers where you are working on a project that you think is going to improve something or some other metric by 0.01%, and you'll be happy that you squeezed out another 0.1%, but really it translates to a lot of money. So those like really interesting place to work. And there's some pretty unique things about working on that team. One, those machine learning models that we ran were I think had some of the strictest requirements for stability in the industry. So, we didn't want any downtime in the ad system. So we had a whole bunch of infrastructure to support that. Also super large scale, super real time. We have to score a whole bunch of ads at query time and return all these scores and run a whole crazy auction really quickly. And it's just a complex problem to try to predict if you're going to click on an ad. And, so we tried to do a really good job of it, but it's always like you can always do more. So that I learned a lot about machine learning on those teams, and
probably set you up to learn a ton about the importance of platforms for machine learning.
Platforms, we had our own infrastructure to support us in the machine learning space to help us train models and evaluate them in real time and all that kind of stuff. So I think most importantly though is I learned a lot about best practices of machine learning, and I learned that at a time when machine learning was still pretty new for a lot of people, and and I think even today we're at a point where best practices for machine learning aren't as widely established as best practices for like regular software development, like checking your code and use Git and run tests before you submit stuff, and et cetera. And that kind of stuff is just not as well established for machine learning. So it's part of the kind of those best practices are kind of what I learned on those teams.
Okay.
And so I've been there for a while, and then about 2 years ago, I joined Uber as the product manager for what was pretty much the only machine learning team at the time. And we began building a machine learning platform, which today is known as Michelangelo. And we recently wrote a blog post and published it to explain what Michelangelo is all about. And basically that's a system to allow internal people within Uber to build machine learning systems and deploy them and monitor them and maintain them at scale within Uber. And so our customers are teams like the team who's trying to predict ETAs, like how long it will take a car to get to you, or the Uber Eats team.
Can you tell them I think they need to work on that a little bit more?
I'm working on it, man. And we've got a whole roadmap to improve this stuff. But that really touches on a real kind of product implications of using machine learning, which is like, how do you communicate and design for uncertainty? Because machine learning, you're making a prediction, and often a lot of use cases, a system will ask for, give me your best prediction, like give me one number back.
Right.
But often a system will kind of know like a distribution, like I think it's going to be this in this range.
Yeah.
And so we try to, when we can, provide like a range of, our confidence intervals for how long we think it'll take some process to happen. And I think we do that well in Uber Eats, but it's the product requires a single number in ETAs, and it's hard to predict.
Right. It's funny how much of this ends up being just kind of UX UI, right? Like if it said, 4 to 8 minutes, it would be, I think, a lot more palatable than 4 and then 8 the next time you look at it.
Yeah.
Right.
Yeah. It's also the kind of thing where we have to work with designers a lot to explain to them the uncertainty that comes with these machine learning systems and help them understand like what level of confidence we actually have with these numbers, so that they can understand what the user experience will be from like once they get these values, once they get the predictions back. But and not ETAs are inherently a really challenging thing. Like there will be construction
Anything
on the
could
street,
happen.
and then your model has to adapt really quickly, and it's a tough engineering problem to solve.
Yeah. If only users thought about how tough the engineering problems were when they were waiting for their Uber.
I think they shouldn't worry about it, and we should just make it a good experience, and they don't have to even consider anything about implementation. Should be magical, and that's kind of like what we're trying to do at Uber is make transportation as reliable as running water. So you don't have to worry about anything. You just open up the app and call a ride, and the ride comes to you.
Right. I want to talk about Michelangelo. I also want to talk about the presentation you did here because you spoke here at the Georgian Partners Conference. Do you talk about Michelangelo in your presentation? Like, will we get to it?
I think I intended to mention it, plug it, but I don't think I actually got to it in the presentation.
Okay.
So, I'm happy to chat about what that's about.
We'll put that on the stack. Also, Horovod. You guys just announced Horovod, and that came up in our last the TWIML Online meetup. Someone mentioned that they saw the news, and we discussed that for a little bit. So I'd love to hear kind of you riff on that for a bit. But let's start with kind of the presentation, and we'll see where that takes us.
Yeah. Okay. So I gave a 20-30 minute talk at this conference today and our summit, and what I tried to get across, the main idea that I tried to get across in this talk is that to actually get enterprise value out of using machine learning systems, of applying machine learning in your company, there's a lot more to do and a lot more to get right than just choosing the right algorithm. And a lot of people focus on what's the right algorithm to use. When you see most of the news we see about machine learning is, so-and-so came up with an advancement in AI that lets us beat this other thing and new accuracy metric and stuff like that. And that's great. And it's totally like a research frontier that's super valuable to have. And But practically what I deal with, and a lot of like the basic machine learning problems that we deal with day to day in most use cases in a company, are issues that can be adequately handled with a very few algorithms. We can apply like gradient boosted decision trees or random forest to a large number of classification problems and receive acceptable results. And so
I forget the stat, but some astounding number of Kaggle competitions are basically just ensembles of those. Just an ensemble
of like those, like a lot of different ones trained in different ways. It's like an ensemble of ensembles.
Right.
And and so if you're trying to like extract value practically in your company and make systems that really use this stuff, the bottlenecks usually are not there in like which algorithm you're choosing. Maybe if you're like building self-driving cars and stuff, where you're really pushing the limits of what AI can do today, then you're dealing with that a lot more. But we deal with a lot more challenges related to infrastructure and data and things like that are closer to typical engineering problems that people usually have to put in a little bit more effort to think about how to do that correctly in the machine learning paradigm. So in my talk, I was talking about a few different areas in which there are kind of like pitfalls where people typically don't, there could be things that if you don't have experience, you don't think about this ahead of time, and you're not planning on dedicating time to solving these problems, or it could just be like tricky things to get right, even if you know what you're doing. And so, one area is technically just infrastructure, solving the infrastructure that goes around your machine learning system. So if you're in grad school and you're learning machine learning, and you're a data scientist, statistician, you get really good at training a Python model or a R model. Your output, your deliverable from that often is like a scikit-learn Python object, or maybe something you can export to like a PMML format. But that's just one part of the story. Like even if you have a great model, there's a lot more infrastructure around your machine learning system that you need to integrate with well. For example, you need a logging system that is aware of the machine learning use case, that can store historical data in a way that's compatible with what your machine learning system wants to do with that data in the future when it's training a model on it. Or you need a monitoring system to be able to accurately monitor and evaluate your model's accuracy over time, so you can determine if your model that you're using in production becomes stale and you need to either retrain it, or if you have some other system that's automatically retraining things, you need a whole bunch of infrastructure to manage that, automatically train, evaluate, deploy, a lot of that stuff. And so my point there is that there's a large engineering investment to go alongside the basic work on the algorithms that a lot of people overlook. And when people think like machine learning is magic, it's really not magic. You still got to put a lot of work into it. So that's kind of one area.
Does that lead you to, like, is there a mature company or a company who's doing machine learning at scale? Is there like a magic ratio of data scientists to engineers?
That's a good question. Well, I'm building Michelangelo, which is we have almost exclusively engineers building that.
Okay.
And our customers are a mix of data scientists and engineers. So the teams that are using our system to actually build these models and run them in production, it's usually like half and half engineers and data scientists. And there's a blurry line between engineer and data scientist sometimes. And so there's often a lot of engineers who just know enough about machine learning that they don't need to consult with data scientists, and they can understand enough about these models to be confident about them. And it doesn't frequently, I don't see it going the other way too much. There's not often like a data scientist who's running like a production system.
Right.
But that can happen. That wouldn't surprise me if I saw that.
And the trend seems to be that they'll be paired, so you'll have data scientists working with kind of this new breed of engineer called a machine learning engineer that has kind of that base level understanding of models.
Yep.
So
what we have at Uber is kind of like the nucleus of a team is an engineer, a team of engineers, usually one product manager and a couple of data scientists.
Okay.
And being an engineer is not just one skill set. And so there are engineers who are very data focused engineers, or there's UI engineers, and the whole spectrum of it. And so usually the folks that partner most closely with data scientists are the more data-minded engineers.
Okay.
But they're not necessarily folks with machine learning specialties. And even on my team, on the Michelangelo team, like most of the work that you end up doing to run a production machine learning system is data pipeline work, workflow stuff. And so we have, I would say probably even most of our engineers are just like data engineers, infrastructure engineers, systems engineers, folks that have picked up a lot of important machine learning concepts, but do not have like PhDs in machine learning or something like that.
And so the idea behind Michelangelo is that, you can invest in building this platform, and then the data scientist can focus on the machine learning and not have to think about the logging and the monitoring and all of these, the life cycle of deploying and managing a model in production.
Exactly. So, about 2 years ago when we started Michelangelo, there were a lot of teams who either were trying to put machine learning systems into production and building their own production stack for it. And different teams were doing the similar thing, but they were all these bespoke solutions that were not, if you're building something for a specific use case, it's unlikely to be supported with a proper engineering investment, and it's unlikely to generalize well when you want to expand your use case, and somewhat brittle and stuff like that. So there was a clear need for a platform to help these teams put something into production and manage something in production. But our goal is to support everything from the exploration side of the data science workflow all the way to production, managing something, maintaining something in production, and the whole operational side of it. I would say that our particular focus is the putting things into production. It's a much harder problem to solve, the helping the teams with like the model exploration stuff. Data scientists have their own tools that they like using, and it's it's hard to do much better than scikit-learn and just letting a data scientist just iterate really rapidly with the tools that they're used to. But when it comes time for them to like begin using that system in production, they usually need to rely on an engineering solution, and that's where our platform comes in.
Okay. And so you mentioned logging, you mentioned monitoring. Are there other kind of main features of the platform?
Well, I was suggesting that there's actually like all kinds of infrastructure, whether it's a machine learning platform or not, that you want to have aware of the machine learning use case. And there's also types of infrastructure that is machine learning specific that you might need to build. So there's a thing that we built, which is a feature store. And so that allows teams to share and discover features. So if you are building the model that predicts how long a restaurant's going to take to prepare a meal for Uber Eats, maybe the model that I'm building would be able to benefit from some of the features that you're using in your model. And so it's a way for us to share features so I don't have to duplicate all the data pipelines to create those features.
And does something like that exist as like a kind of a metadata catalog that is, mirrors a data store like a HDFS or something like that?
Yeah, so for us practically, you can do a few things, but basically we manage metadata layer to understand where these features are stored, and it is all in like Hive HDFS, and other people can contribute to it, or we have this other way where we manage some core set of features, and we're still figuring out like how we can make that most usable to other teams and really nail the sharing of this data use case, because it's super tricky, because if you're building a production system, you are going to be hesitant to rely on a data set that you don't own. And you don't know if that person is going to change how that's calculated the next day, and it messes up your system. So we're trying to like figure out what the right contracts are to guarantee certain data stability and quality and stuff like that.
Like how far along are you on defining what it even means to have a contract? Like it's hard enough for services which have a fairly small surface area, right, of the API, but it strikes me that data has a much more kind of expansive surface area around what you need to try to define a contract.
Yeah, I haven't spent enough time on this area to have really figured out where we actually want it to be. So I can't even say if we're 20% there or 50% there, because I really don't know how much more we want to do in this space. So that's tricky. I think it's an area that we probably want to prioritize more. And like another thing that comes along with that is, that's HDFS Hive, that's all offline stuff that's ready for batch processing. But there's a whole other side to this where if you're running an online prediction model, you want these features to be generated in real time. And so you might have some real-time stream processing stuff that will calculate those same features, and you want them to be calculated in the same way as you calculated your offline batch data that you trained your model on, but you're calculating these features in real time and then making them available to your model so your model can score. And this could be like understanding a good example is how many meals has this restaurant, how many orders has this restaurant gotten in the past 30 minutes? And that might be like so
you need to window and figure out how you're going to accumulate. And it's like you've got this repository that says what your features are, and then you've got your kind of your meta that's like how you derive the features from the underlying stream of data. And so you can imagine there's a large activation energy to set up a system like that. And so that's part of the value of having a platform that builds all this infrastructure and plugs it all together nicely. So you just need to provide a configuration and say, hey, use this data and give me this real-time feature. And that, we found that kind of infrastructure has really lowered the activation energy. So we've allowed like those teams who are building these bespoke solutions, we built a good system for them, and they've kind of pivoted onto our system and begun using our system. But also there's teams that before didn't have the resources to even take on a machine learning project, but they've known that they want to have some kind of predictive solution in their product. And
the lower activation energy to get started has kind of helped them unlock that, and they've been able to fund a product because or such a project because the cost has come down so much.
Nice. Now, so we've talked primarily around what I kind of roughly think of as engineering-facing features and infrastructure, but there's a whole set of operationalizing features. You may remember me getting into part of this conversation in an interview with Jennifer Prinke, who was at Walmart Labs at the time, not too long ago, and kind of the direction that they were heading. And I could see Michelangelo going in this direction, if it's not already, is, you've got a model in production, like, are you tracking kind of either statistical drift of the inputs or, model accuracy, decreasing over time? And then like automatically triggering, or at least like setting a ticket or something like that to reevaluate the model. So the kind of the full like service level impact of these models. Do you get into that at all?
So this is, we do get kind of into it, and this is an area that we're really trying to focus on over the next couple of months, is build out there's a lot of things you would want to do to operationalize and maintain such a model. So things like tracking the data quality both in and out of your model. So you might want to do things like track feature distributions over time in real time. So all the data that's coming into your model, does it look different in this 5 minutes than it looked in the past? And you might compare that to the distribution of data that you saw an hour ago, but also like the historical distribution of like the past 2 years of data like that. And has that changed?
Just sorry to interrupt, but
go ahead.
When we were talking about data and contracts around data and models, like one of my thoughts was, is part of that contract like a statistical distribution of the data at a point in time, so that you can refer back to what you thought that data looked like when you built the model.
Right. So that's not something that we would necessarily want the customer to explicitly provide, but it would be something that we may be able to extract from the training data. So we might be able to say like, look, this is the distribution of the data we saw at training time. Let's kind of save a snapshot of the summary statistics, and then compare our normal like the data we see in real time to those statistics. And so sometimes like, your training data, you might rebalance classes and reweight things and stuff like that. And so there's some complication to take that stuff into account. And so this is some of the challenges that we're working through right now.
Okay.
But then there's also the other side of like doing the same data quality checks on the output of your model, like the predictions, and doing the same statistics tracking stuff. And you would also want to have alerting happen on that kind of thing. And that's all part of this like larger infrastructure integration story, because your company should have a way to like set up alerts for production systems, and so you just want to integrate with the basic stuff that you have.
Right. Cool. So we didn't get very far into your presentation.
I was talking a lot about like the infrastructure side, which is, the summary is you got to do a lot of engineering work before you get into to put one of these models into production properly. There's also another part of it, which is building tools to help the data scientists do their job properly, both correctly and productively. And so there's many parts of the data science workflow, and if you leave data scientists, if you don't support them with the proper tools, then they may be building systems in a non-reproducible way. So there's not a way to like recreate the model if you need to retrain it. It may not be all versioned and source and like checked in and source controlled and stuff like that. And you may not even have standardized ways to evaluate these models. So you may just waste a lot of cycles comparing data scientist A's evaluations to data scientist B's evaluations, because there's not a common set of metrics that everybody's agreed on ahead of time. So there's some work to provide some infrastructure for them as well. And so the feature store is one example. It gives a kind of like common source of truth. But beyond the technical stuff, there's a lot of organizational considerations when you're trying to make the most out of machine learning in your company. So, the one thing that's important to understand is that not everyone's an expert at machine learning, and people come with different levels of abilities and background knowledge of machine learning. So that leads to a lot of times when people have false conclusions about how machine learning can be applied to their problem. So some people will tell me, well, I don't think machine learning can help with my problem at all. So we don't need to like have a collaboration. And then when we look into it, we realize, oh, well, actually, the main problem you're trying to solve is pretty appropriate for a machine learning solution. Or there's folks who have told me, have kind of conveyed that they believe machine learning is basically magic and they think it can solve all of their problems. And that's a kind of thing where you really want to understand those expectations and adjust those expectations to be much more realistic, so you don't have a problem down the line of completely missed expectations. But then there's also people who are almost like overconfident about what they know about machine learning, and they request specific algorithms or specific implementation. And the example I gave in the talk was someone once asked me, mentioned that they need unsupervised online deep reinforcement learning or something like that. And I was like, okay, it's like, I don't know if that's a thing, but we should understand what your problem is. So like the way to handle most of these situations is to not really focus on the machine learning part of it, but to really just like talk to these people and understand what the business problem they're trying to solve is, and not involve machine learning vocabulary. And you know, I'm the product manager of our team, so part of my role is to understand the business problem and find a way to translate it into a machine learning problem, something that we would be able to solve, and understand also
something
if it's
that
even
you'd be able to solve, or something that you'd be able to support with
both. So we have we also have an applied machine learning team that we is
kind of like a tiger team that supports the different engineering groups.
It's kind of like a set of machine learning specific data scientists that these folks may be able to like put on loan to a team to help them solve a machine learning problem if they don't have the resources when it's a particularly relevant and important machine learning problem. So like I help kind of coordinate these types of problems. And so we figure out like if it's a relevant problem and how we might be able to solve it. And ultimately, I'm trying to understand the business metrics that these people are trying to optimize for, and understand the mechanisms that the whole product works. So what they think actually affects those business metrics. And then I'm trying to translate that problem into for our data scientists, or for their data scientists who might need help with it, like a machine learning problem that where if a data scientist is optimizing for precision recall or all the other kind of data science metrics that they would be used to that are related to machine learning, as they optimize for those would likely be an appropriate proxy for optimizing for these end business metrics. And so it doesn't always work out perfectly, but it's a good way to like start things off. And ultimately, you want to have people who understand the whole problem end to end to really like think things through. But it's a good way to get started in that kind of area. So like talking to people at the right level of like vocabulary, you know, focusing on the business problems, expectations, making sure they don't think that machine learning is magic, setting that properly. Another thing that I found useful is going out of my way to find a senior person in the company who really understands machine learning, or like taking the time out to educate them about machine learning. So I can always have them on my side if I ever need to defer to someone more senior. I know that there's someone there who will either be sufficiently technically competent to be able to make the right call, or that I've spent enough time with so that they'll trust me to make the call when it comes to that. So that I found that to be useful. And then another thing that is also useful for figuring out how to make the most out of machine learning is realizing that you're not going to have infinite machine learning experts. And so you have to find a way to make the most out of the limited number of machine learning experts you have.
And what's the answer to that challenge?
It's tricky. It's like, how do you set up your org, right? It's like, how do you distribute your machine learning folks across the different teams? And there's different ways you can do it. So I mentioned that we have this applied group, which is which is kind of like a solutions team in some sense, where they're a team of a few data scientists who are experts at machine learning, and they kind of are out on loan to different teams that need help that don't have the machine learning expertise. And so you can imagine there's these different engineering teams, and then there's one kind of like cluster of machine learning people on a separate team that loosely interact with those teams. But another model is you could just embed one machine learning person or one or two on each of those teams. And so that model is slightly more difficult to scale because you have a new team and then you need another machine learning person. And so I think we've experimented with different models. Different models will work well for different size companies. Often it's not just a binary thing, but there could be like a hybrid where you might lean more to one side or another. And in practice, we might have things where our applied team might start off a project, but then hand off a project to a data scientist on that product team at some point. So like thinking those things through explicitly ahead of time and being realistic about how many resources related to machine learning that you have, that's pretty valuable. And so that kind of covers the organizational things you want to think about when you're launching machine learning systems. And then finally, just like team focused things, which are like, how do you, when you're running a machine learning project, what can you do to like organize your machine learning project to be set up for success? And there's a few things that are kind of just like questions you want to ask yourself and like rules of thumb you want to apply. So one is about like not artificially encapsulating the machine learning specific part separately from the non-machine learning specific part of your project. Like you don't want the person who's building the model, who's generating these scores, to not know anything about how these scores are being used. And so there's a lot of ways that these scores can be misused, and a lot of like nuance in how these scores are generated. And
we talked about the inverse of that, which is the designers and the app teams not really understanding the scores and the probabilistic nature of the scores.
So that's part of like that's part of like how you would design a project to a product rather, to make relevant use of the machine learning scores that you're providing. And then there's other examples of this, which are more like, your scores can be used in a way that they were not intended to be used. And when they can even be used in a way that can harm your machine learning model. If you have a certain feedback loop where, if you're trying to predict churn, for example, and then someone uses these scores to provide some treatment to the people who are most likely to churn, and then they solve the churn problem for the 10% most likely to churn people, then those people didn't churn. And then when you go to retrain your model next month or 2 months from now or whenever, you'll not have those labels that those people churned. And so your training data is going to be kind of messed up. And so that's not like a particularly hard problem, but you just have to, if you don't think about that ahead of time, if you're not thinking this problem through end to end, and you're not aware of how these scores are being used, then you may not include that in your design of the whole system. And so your whole project might be flawed from the beginning.
And is a solution there to flush your labels when you make changes like that?
There's other things you could do. One could be just have a holdout set. So you you never apply treatments to some X% of the people that you're making predictions for. So then you can always reserve them as like the control, the untouched people that you can train your model on in the future. Or you can, even like a more advanced way is find a way to include that treatment in your modeling in the future. So your model is aware that maybe these people didn't churn, but it was because they got this treatment. And so this kind of, that has more of a feedback loop, and so it's more complicated. You need to think about it more deeply. But overall, like I'm on the team side, it's, you really want your folks who really have an attitude of ownership of these systems to be the most involved here. You want them to be kind of almost like borderline paranoid about the operation of these systems, asking questions like, if the world changes, is my model going to be able to react to it? And how will my model react to it? Or like, how a feature is computed by the logging people, or if it's how it's recorded changes slightly, like they use a different format they store it int now instead of a double, is that going to mess up my number, my predictions? And how can I prevent that from happening? Or like, how will I notice if something's wrong? Or any number of things, or even like on these different dimensions, like legal and cultural things, like based on how these predictions are being used, is there any bias that's inherent in this model, and will that have some impact in how the model is perceived, like legally or culturally? And that's always a tricky problem, and often not just one person can think through all of these problems, and you want like a kind of like a good citizenship attitude, because no one's particularly singularly responsible for these issues.
Right.
But you just want people to really think things through and really own this system, so they are always feeling like they're doing the right thing here as well.
Okay. So we covered, I think, the topics in your presentation. I wanted to make sure we hit on Horovod before we move on. What's that all about?
So we have a lot of data at Uber, and we've been trying to get started running distributed TensorFlow. And we ran into a lot of issues just setting up the parameter server constellation and connecting everything together in the proper way. And we've got an engineer, Alex Sergeev, who's awesome. He's a genius, and he found a way to kind of improve upon the Baidu's a paper that Baidu published, where they open source some code to have a different way to distribute the work in TensorFlow. And
so it's basically ripping out the guts of the distributed stuff and replacing it with OpenMPI.
Exactly.
Which harkens back to the great computing days.
Yeah. So it uses like the ring all reduce method, and you have if you have n nodes, each node is only sending data to one other node and receiving from one other node, and there's no parameter servers. All the workers are communicating with other nodes and are averaging up gradients in that node itself. And so you kind of like set up this ring of connections between, like a circle, like align them all in a circle. And so then if you pass one message through, and you keep iterating your message passing, eventually one signal will get all the way around and be distributed to all the nodes. It's much easier to understand visually if you see it.
We run into that problem sometimes on the podcast.
But so Alex built this awesome system that is called Horovod. Horovod is a Russian dance that people link arms in a circle, and so it's kind of like the right imagery there. And so he's been applying it to a lot of our distributed learning problems, and he's found that it's much easier to set up a distributed learning job in TensorFlow. So there's a lot of boilerplate code that you need to have in a existing parameter server TensorFlow paradigm to like allow it to all be distributed. And he's figured out a way to have only 4 lines of code that you need to add to a TensorFlow script to distribute it.
Wow.
And
I've heard not great things about trying to distribute out of the box TensorFlow.
It's pretty challenging. I don't know exactly. I don't know exactly what Google does internally, but I think they're probably working on an improvement to it.
So from what I've heard, they're trying to, or at least someone is thinking that at some point, they've got this Kubernetes thing that's kind of good at distributed compute. They've got this TensorFlow thing. Hey, somehow we can kind of get the chocolate and the peanut butter together. And,
yeah. So I mean, I'm sure there's a whole team working on that at Google. And so this was just like Alex on our team needed to solve a problem for himself immediately. And so he built this system. And it's really easy. If you check out the blog post we have, just search Horovod.
Not just blog posts, it's open source. It's
open source.
Right?
You can just go download it and check out the sample code, and it's literally just add 4 lines to your TensorFlow script and you're good to go.
Wow. And hearing you describe it goes higher up in ripping out the guts than I even thought. Like I thought it was just like using kind of MPI as like a low level message passing thing, but it's also kind of changing the way gradients are distributed across the system.
Yeah, it touches various layers there.
Yeah.
So Alex has been able to use it to, let me see, I think there was some model that took maybe like 10 days to train, and on our cluster with, I don't remember the details, but in some real practical application, he was able to train this model in 7 hours instead. And
cluster of how many nodes?
I don't know how many he used in this particular thing, but we've trained stuff up to maybe 128 GPUs.
That's right. And now that I mentioned that, I remember the graph that was in the blog post, and you get pretty darn close to ideal multipliers on the scale. It was pretty impressive.
Yeah, it's pretty. I mean, it's a very large speed up for really big applications.
Yeah.
And you can imagine if you take 10 days to train your model and then suddenly you can train a model in 7 hours,
right.
That changes your whole workflow. It changes like what your job is.
Right.
And so that team's productivity has been changed dramatically. And there's not that many use cases that absolutely need like so much data. Mm-hmm. So we're still trying to figure out if there's ways that it can be useful to speed up like smaller use cases as well. But it's always something good to have, because people aren't going to begin training on less data. People are always adding more data, and so that's what's happening to our use cases.
And is this an example of something that would get integrated into the Michelangelo platform, or
this is part of the Michelangelo
part of the platform?
Yeah, and so it wasn't mentioned in our Michelangelo blog post, but we're working on kind of like a separate development model exploration, deep learning specific IDE kind of, or IDE is the wrong word, like
a framework or something?
Yeah, kind of like a framework for people to easily run containers and TensorFlow and iterate on TensorFlow models and get a bunch of machines that they can, like GPU machines, so they can run these big distributed jobs. And then ultimately have those models appear in Michelangelo so they can push them to production and evaluate them and stuff like that. And that's how Horovod fits into Michelangelo. And I think we're just going to see a tighter and tighter integration in the future. So
and now Horovod is open source. Michelangelo is not.
Michelangelo is not. I'm still trying to prioritize that in our roadmap. It's a lot of work to open source something. So don't blame me. A lot of people have gotten a lot of emails like, "Hey, so I couldn't find Michelangelo on GitHub," and I was like, "Oh,
nice Medium post. Where's the code?"
Sorry, guys. But I hope to be able to open source it at some time. It's just not something we're working on right now.
Well, it's I think as people deploy, as people kind of productionalize machine learning more and more, like they run into this. They have to run into this, and at every place, like the problem that you're trying to solve with Michelangelo, preventing data scientists and engineers at Uber from building this over and over again. We're doing this like on the scale of the industry. And, there are like a handful of proprietary, kind of all-in-one platforms that kind of solve some of it. And I forget the name of the company, but I recently came across a company that is, their focus is trying to solve the kind of model lifecycle and production thing. But, I think ultimately, it's infrastructure, right? And infrastructure wants to be open source.
Yeah,
right.
Totally.
So you guys should open source it.
I know. I think it would be cool if we did.
What's up with that?
I'll bring that feedback back. I know I'm arguing for it too. So, I think it'd be cool if we did, and I would definitely love to see like an industry-wide adoption of Michelangelo. I feel like we have a lot of high priority stuff we got to add to it internally. But there's definitely, there's a lot of benefits to open sourcing stuff. And I think that's why Google open sourced TensorFlow from the beginning. They worked on it a lot internally, but then when it was good enough, they open sourced it. And as far as I understand is because they didn't want to have the same thing happen to them as what happened with MapReduce, where they didn't open source it at first, and then and then there was a big deviation from the open source stuff than what happened when they got
someone else open sourced it. And they were kind of left out.
So
awesome.
There's a lot of benefits. We'd love to do it sometime.
Right. Well, Mike, I really enjoyed the conversation. Thanks so much for taking the time to sit down with us and share a little bit about what you and Uber are up to in the realm of ML platforms.
Awesome. It was a pleasure being here. Thanks a lot.
Great. Thanks.
All right, everyone, that's our show for today. For more information on Mike or any of the topics covered in this episode, head on over to twimlai.com/talk/115. Definitely remember to vote on your favorite My AI video at twimlai.com/myai. And of course, thanks so much for listening, and catch you next time.